The main disadvantage of these white fluid phenols is that they are toxic and they have a tarry odor. So since they have been made up of the low boiling point tar fractions, so that's why, so if the emulsion breaks up, or if the formulation is not prepared in a good manner, so then definitely it may be having a tarry odor. And they are toxic also, definitely. So because most of the disinfectant which are toxic to the microorganisms, so they are also toxic to the human beings. And if the emulsion breaks down, so they leave a tarry deposit. That means definitely, so since it's an emulsion, it is made up of low boiling point tar fractions. So that if the emulsion breaks down, so that tar fraction, it will get separated, and that fraction, it may leave a tarry deposit on the surface when if the emulsion is broken down. That is very rarely it occurs, because the emulsion will be prepared in a very proper manner. So that's why problem should not come. But if emulsion is not prepared properly, or if the formulation is not prepared properly, so this problem may occur. So the composition of this white fluid phenol, so which usually we call it as the phenol. So it contains cressylic acid 20 equivalent to the 27% of the phenol, which is having 68% weight by volume by volume, and the cresol, which is equivalent to 99% phenol, so it is present in the 7 parts, that is the 7% weight by volume. And apart from that, it contains the WW rosin, so which will be usually the fragrance which will be used, and soybean oil, caustic soda, and castor oil. So they will be used for the formulation, that is for preparing the emulsion, and also the water is used as a diluent. So then coming to this black fluid phenol. So these black fluid phenols, so they are based on the tar fractions of the high boiling point than that used in the white fluids. So here the composition of this tar fraction will be, they will be having the higher boiling point tar fraction than compared to that white fluid phenol. So which are the fractions which are used in the white fluid phenol. So this tar fraction is a complex mixture of higher homologs of the phenols, naphthals, indenols, anthracols, and other phenolic compounds. And it is quite insoluble in water and must therefore be solubilized in a neutral oil. So these compounds, since they are being the high boiling point compounds, and they are most of the non-polar in nature, and their solubility is very much problem in the water. So they are quite insoluble in the water, and definitely they should be solubilized in the neutral oil. So after the solubilizing in the neutral oil, then it will be formulated in the form of the phenol. So this mixture is then solubilized with the soap solution, or an ethoxylated castor oil sulfonate, or glycerol, or the glycols. They may also be added during the formulation for the solubilization. So advantage of these black fluid phenols is that so these products are effective against a wide range of gram-negative and gram-positive bacteria, and their level of fungicidal activity is quite high compared to the white fluid phenols. So these products are effective in conditions of heavy soiling. So once again, similar to that of the white fluid phenols, so these black fluid phenols are also effective, or they are most efficient whenever the soilage or the soiling, that is the presence of more of the organic matter and soiling is present. So at that time of also, so they'll be having very good activity. They coming to the limitations or the disadvantage of this black fluid phenol. So the high boiling point tar acids, so they are used in this product, and they do not have the same wide spectrum of activity as those used in the white fluids. So that means their spectrum of activity is comparatively less. So whereas the white fluid phenols are having very broad spectrum of activity, so they are active against more number of, or the variety of microorganisms. But whereas in case of the black fluid phenols, so their spectrum of activity is comparatively less. So usually they are relatively ineffective against the some of the bacteria like the Pseudomonas species as well as the mycobacteria. And usually the formulations have also been developed using this triethanolamine dodecyl benzene sulfonate as an emulsifier. So in the recently, this molecule, this emulsifying agent is being used in the preparation of this black fluid phenol. See, in case of preparation of the phenol, so it may look very easy. So one the simple disinfectant what we prepare, usually students prepare in the lab, is the cresol with soap solution. So it's a very simple preparation. But when it comes to the household or the which are the these disinfectant which are prepared for the hospital purpose and other thing in the market, so they need to have a proper formulation, because they have to be, because I have already told you that these disinfectants are not usually purchased in small quantity. So they are purchased in quite a large quantity and they'll be stored for a long period of time. And during that storage, so these disinfectants should be stable and they should have they should retain their effectiveness. So that is the reason preparation of the formulation of this disinfectant is very, very important. And once again, we know that there are a number of factors which are going to affect these formulations also, and definitely it will affect in turn the activity of the disinfectant. So the one phenol worthy of this special mention in this case is the O-phenyl phenol, so which is also being used in the preparation of this black fluid phenol, and this can be incorporated into the clear soluble products and is quite often used in combination with the halogenated phenols, so to enhance their activity. So it is O-phenyl phenol is less toxic and less corrosive than most other phenols. And formulating with the phenols, it requires the great care. As the activity of the formulation, it relies on both the oil-water partition and micelle concentration. So one is the solubility of the phenols which we are using. So if they are highly water soluble or they are water insoluble. So that is very, very important, because if they are water insoluble, then they are soluble in the oil. So that is the reason while preparing the formulation, we have to keep in mind regarding the partition of these phenols between the oil and the water, that is with the non-aqueous and the aqueous phase. And also when we are using the soap solution, so definitely while you are using the phenol, we use the soap as one of the emulsifying agent in order to stabilize the emulsion. So the micelle concentration, I have already told you. So what is the effect of formation of the micelles while using these surface active agents? So this micelle concentration is also very, very important. If the micelle concentration it increases, so definitely it is adversely affect the activity of these phenolic compounds or these disinfectant formulations. So that's why we have to keep in mind the micelle concentration and also the solubility of these phenols between the oil and the water. That is the partition between oil and the water. And based on that one, these formulations has to be prepared. So coming to the composition of this black fluid phenol, so that is which we call it phenol. So it contains an ingredient for the soap solution, which will be 20% of the total formulation. It contains the rosin, castor oil, caustic soda, and the normal water for the preparation of this soap solution. And as a preservative, we call it LCO. And for as a disinfectant, we use 1.5% of the parachlorometaxylenol. So this is the parachlorometaxylenol, which is being used as mainly as a disinfectant here. And also the water is used as the base, which will be of 66%. So this is how this formulation of this black fluid phenol can be prepared. That is the what we regularly use at the household. So that is regarding the white fluid phenol and the black fluid phenol. So any question till now?
No, sir.
Okay. So now let me continue with that the evaluation part. Before that, let me take the attendance. Okay. So now let us once again come back to the evaluation of these disinfectants. So we have seen the Riedel-Walker test. So where we as an organism and the different concentration of the disinfectant and the concentration of the phenol with some network issue. So now Am I clear now?
Yes, sir.
So now there are certain disadvantages in the radial Walker test, in the radial Walker coefficient. So in order to overcome that, so we have using one more method for the for determination of the phenol coefficient. So the another method is it's called as the Chick-Martin test. So this test also, it will determine the phenol coefficient of the test disinfectant. So it compares with that of the phenol, similar to the radial Walker test, but the procedure is slightly different. So unlike in radial Walker method, where the test is carried out in water, so the disinfectants are made to act in presence of a yeast suspension or 3% dried human feces to simulate the presence of the organic matter. So in radial Walker test, what we do, the organism is inoculated or organism is put into the different dilutions of the disinfectant as well as the phenol. So that dilution, different dilutions of the disinfectants, it will be prepared in the water, regular water. But that condition, it does not simulate the presence of the organic matter when we are using in the regular condition. So definitely when we use the disinfectant on the table or on the laboratory or anywhere, so at that time, so definitely it will be containing some organic matter will be present on that one, and that is going to affect the activity of the disinfectant. So that will not be taken care in case of the radial Walker test. So that is the reason in Chick-Martin test, so the organism is put into the different dilutions of the disinfectants, and this dilution of the disinfectant is done in presence of the diluents which we use. It contains either a yeast suspension or a 3% dried human feces, so which will simulate the presence of the organic matter. And time for subculturing is fixed at 30 minutes, and the organisms used in the test efficiency is the Salmonella typhi as well as the Staphylococcus aureus. Whereas in case of the radial Walker test, we do the subculturing so that we transfer the organism to the recovery media after 2.5 minutes, 5 minutes, 7.5 and 10 minutes. But whereas in case of Chick-Martin test, we subculture it only once, so that will be at 30 minutes. And also we use two different organisms here. So two set of experiments will be done. One with the Staphylococcus aureus, another one with the Salmonella typhi. So the two different organisms will be used here. So the phenol coefficient is usually, it is lower than what is given by the radial Walker method. So definitely it should be less, because in case of the phenol, the radial Walker test, so the conditions are not too harsh, but whereas in case of the Chick-Martin test, so the conditions will be harsh. So that's why definitely, so that phenol coefficient, which is determined by using the Chick-Martin test, it will be comparatively less than that what we determine by using the radial Walker test. Suppose in case of, if you determine the phenol coefficient test by radial Walker test and it shows that it is 10, and the same disinfectant, if you do it by Chick-Martin test, so definitely it may be less than the 10. So this is actually the difference between the radial Walker and the Chick-Martin test. So remember this particular slide, or you concentrate here, because in the examination most of the time for 5 marks question, you may be asked, write the difference between the radial Walker and Chick-Martin test. So these are the differences we should be able to write. So one is the volume of the medium. So the media what we take for in the recovery media. So in the radial Walker test, we take 5 ml of the media, recovery media, and whereas in the case of the Chick-Martin test, we take the 10 ml. Second one is the diluent for the test disinfectant. So the test disinfectant, whether it's a phenol or any other disinfectant, the dilution is done in water in case of the radial Walker test. But the same in case of the Chick-Martin test, this dilution is done in a suspension containing the yeast suspension or the 3% dried human feces. And in case of radial Walker test, the reaction temperature, that means the reaction between the disinfectant and the organism. So that will be tested at a temperature of 17.5 degrees centigrade. So which is the lesser temperature for the pathogenic organisms to grow. So you know that the growth temperature for the pathogenic organisms is slightly on the higher side. So whereas, so this test will be conducted at 17.5 degrees centigrade. So, and this condition will not simulate the ordinary room temperature. So that's why in case of the Chick-Martin test, So this reaction temperature will be maintained at a 30 degrees centigrade. So which is a common or average room temperature in most of the places. And organism used in radial Walker test is only one, that is Salmonella typhi. And whereas in case of the Chick-Martin test, we use the two different organisms. So one is the Salmonella typhi and another one is the Staphylococcus aureus. And the next difference is the sampling time. So in case of the radial Walker test, the sampling time is at 4 different timings. So at 2.5, 5 minutes, 7.5 minutes, and 10 minutes. So at the 4 different times, the sampling or the subculturing is done. But whereas in case of the Chick-Martin test, the subculturing is done or the sampling is done only once. So that is at the 30 minutes. And calculation of the coefficient. So whereas in radial Walker test, we calculate it as dilution of the test killing in 7.5 minutes divided by the same as that of the phenol. But whereas in case of the Chick-Martin test, so there is it will be taken the mean concentration of the phenol showing no growth after 30 minutes and divided by the same for the test. So why this difference is done? So in calculating the coefficient. So here in case of the radial Walker test, what we do, we see the concentration, which concentration will kill the organism at 7.5 minutes, but not at the 5 minutes. So now what is the difficulty over here? Sometimes, so this killing at 7.5 minutes, it could be even the killing may be at 5.1 minute. Okay, so that killing at 5.1 minutes, so how we consider, what time we consider? We consider it as 7.5 only. The organism might have killed, it might not have killed at 5 minutes, but it might have killed in 5.1 minute or 5.5 minutes or at 6 minutes or 7 minutes. So definitely it need not be as 7.5 minutes exactly. So that gap of that 2.5 minutes, so anytime that killing might have occurred, so that will not be considered for the calculation. So that is the reason here, in this case, only one fixed time is taken. So that will be that concentration which shows at the concentration of, the concentration which shows the killing at the 30 minutes. So that will be taken, so fixed. So there is no point that it is not killed at 5 minutes, it will kill only at 7.5 minutes, that will not be done. So to avoid that problem, so it is having a fixed timing here in case of the Chick-Martin test. Is this clear? So the difference?
Yes, sir.
Hmm?
Yes, sir.
So because I need answer, because most of the time you will be getting this question, the difference between the radial Walker and Chick-Martin test. So that's why I'm stressing up on that one. Okay, if there are no questions, then let me continue. So now, so how we, here you might have not understood. So the mean concentration of the phenol showing no growth after 30 minutes divided by the same for a test. So how it is done, how the calculation is done in case of the Chick-Martin test. So now we can see here the Chick-Martin coefficient, it is calculated by dividing the mean of the highest concentration of the phenol permitting the growth in both the cultures. That is, both the cultures means we are using Staphylococcus aureus and the Salmonella typhi, both, and the lowest concentration showing the absence of the growth. So here you can see in this one, in case of the phenol, and this is the test disinfectant. So different concentrations are used here. So in phenol, we are using the concentration of 2%, 1.8%, 1.62%, and 1.46%. So which are the two readings we take for the calculation? So we take for the calculation the two readings, that is, one is the highest dilution, the lowest, what we can call it as the highest concentration of the phenol, which is permitting the growth. So that will be 1.62 minutes, sorry, 1.62%, and the lowest concentration showing the absence of the growth. So this is the absence of the growth. The lowest concentration is 1.8. So these two concentrations will be considered. Whereas in case of the radial Walker test, we are considering only one concentration. But here we are taking the mean of these two. That is one, the concentration which is showing the activity, showing the activity that's killing all the organisms. The one concentration which is not killing the organism. So the mean of these two will be taken, and here the mean is 1.71. And similarly for the test disinfectant also it will be done. So here it is the mean of 0.41 and 0.37. So 0.41 is one which is not showing the growth. That means which is killing all the organisms, whereas 0.37, so there is a growth, that means it is not killing all the organisms. So the mean of this is 0.39. So now how you will calculate the Chick-Martin coefficient? So the Chick-Martin coefficient is equal to the concentration, the mean concentration of the phenol divided by mean concentration of the test disinfectant. So 1.71 divided by 0.39. So that will give you 4.4. So the phenol coefficient also by using Chick-Martin test is here, it is 4.4. So this is how the phenol coefficient test is calculated by using the Chick-Martin test. Now tell me, is it clear?
Can you repeat once again, sir? This calculation of coefficients.
Which one? Calculation.
Calculation.
Okay. See here, in case of the Chick-Martin coefficient, we perform this Chick-Martin coefficient. I will tell you the in brief the procedure how we do. So here we'll be using two different organisms. One is the Staphylococcus aureus, one is the Salmonella typhi. So okay, these two experiments will be done separately. So usually 24-hour culture of any of these two organisms is taken, and it is added to the different concentration of the phenol and different concentration of the disinfectant which need to be evaluated. So here you can see what are the concentrations we have used. For the phenol, we have used 2%, 1.8, 1.62, and 1.46. And for the test disinfectant, we are using 0.46, 0.41, 0.37, and 0.33 percentage. So now we add the organism to this reaction mixture or the dilutions, different dilutions. And once it is added, it is maintained at 30 degrees centigrade. And after 30 minutes, so the organisms or the sample is taken from this this reaction mixture, which containing the different dilutions and the organism. So it will be transferred to the recovery media. So in that recovery media, once again, it is kept at 37 degrees centigrade, 37 degrees centigrade for 2 to 3 days. So now, after 2 to 3 days, so then we'll check for the growth or the no growth of the organism. So here you can see, once this is what the result, the example of a result, what you got. So at 2% and 1.8% of the phenol, so there is no growth. And the same at 1.62 and 1.46 percentage, there is a growth of the organisms. So that means in that 30 minutes reaction time, so only the 2% and 1.8% is effective, whereas 1.62% and 1.46% is not effective. Similarly, in case of the sample disinfectant, so at 0.46% and 0.41 percentage, there is no growth, so which shows the activity within the 30 minutes. And at 0.37 and at 0.33 percentage, so there is a growth of the organism. Now for the calculation purpose, so in case of the Riedel coefficient, what we used to do is we have to take only the concentration which is showing the activity, but not in the different timing. So, but here we are fixing the time, that is the 30 minutes. So that's why what we do here is to avoid any complications. So we take the mean of two concentrations. So that is the lowest concentration, which is not showing the growth, and the highest concentration, which is showing the growth. And in this case, so here it is 1.8 percentage, that is the lowest concentration, which is not showing the growth, and 1.62 percentage is the highest concentration, which is showing the growth. So the mean of these two will be taken, and here it is 1.71. So similarly, the mean of the sample disinfectant is also taken, that is 0.39. So the mean of the highest concentration, which is permitting the growth, and the lowest concentration, which shows the absence of the growth. And Chick-Martin coefficient will be, so this mean of the highest concentration, mean of the highest concentration, which is permitting the growth, and lowest concentration, which with absence of the growth of the disinfectant, of the phenol, divided by same as that of the disinfectant. So simple, dividing the concentration, the mean concentration of the phenol divided by the mean concentration of the test disinfectant, you will get the Chick-Martin coefficient. So this is how the Chick-Martin coefficient will be done. Is it clear? Okay now?
Yes, sir. Yes, sir.
So this method also has got certain disadvantages. We'll discuss that later in the later stage. So when we see the next method. So the one more method, what will be most commonly used in the recent days, is called as an AOAC method. This AOAC method is a association of official analytical chemists phenol coefficient test. So this AOAC method, it is once again a phenol coefficient method, phenol coefficient test method, which once again use the phenol coefficient. But here there are slight differences in the procedure. The main difference is the neutralization of the bacteriostatic effect. I have told you in the beginning. So when we transfer the organism to the different dilutions of the disinfectant, after the reaction time, we transfer it to the recovery media. So when we transfer that to the recovery media, so there may be a small quantity of this disinfectant may come in the recovery media. And that small quantity of the disinfectant in a over a period of time, so where we'll be keeping for 2 to 3 days, so definitely it may act as an bacteriostatic agent. So when it acts as a bacteriostatic agent, so that time it may not allow the organisms to grow that concentration, the small concentration. Even though the organisms are live, so that it may not allow the organisms to grow that bacteriostatic agent. So that's why. So in case of the radial Walker test or in case of the Chick-Martin test, so we are not neutralizing that bacteriostatic effect of the disinfectant, but which will be taken care in case of the AOAC method. So this method is applicable to the testing of disinfectant which are miscible with the water. So usually most of the disinfectant, they will be miscible with the water. They have been formulated in that manner. So usually the neutralization of a bacteriostatic effect, it can be achieved by using the different specified media which containing the lecithin, 280, cysteine or the thioglycolate. So depending on the chemical nature of the disinfectant which we are using, and we have already studied in the factors affecting the disinfectant activity, so which are the inhibiting agents which will be used for the different types of the disinfectant. So similarly, when we are here, we are using the media which containing either this lecithin